Okay, this is our light waves study guide. So we got our test on Thursday the 25th over this unit. So let's go through some stuff about light waves. All right, so light, remember, is made up of all different kinds of waves that are part of this electromagnetic spectrum. Okay, so what type of wave is light? Is it transverse or longitudinal? Light is a transverse wave. Remember, that's the one that looks kind of like this, like our traditional kind of waveform that we think of. This is where the energy and the direction of the vibration are perpendicular to each other. Okay, so let's write that. So if this is displacing matter, it's doing it in a manner that's perpendicular to the energy direction of the wave. And then electromagnetic spectrum gives this one away. Kind of light waves are electromagnetic waves, which means that they can travel in a material. So they can travel through like solids, liquids, gases, and in a vacuum. So they can also travel in space. Remember, mechanical can't travel in space. They've got to have a medium of some sort, and that's like sound waves have got to have some kind of material to pass through. So, okay, arrange the waves of the electromagnetic spectrum from highest wavelength to lowest wavelength. Okay, um, so let's say wavelength highest to lowest. So our highest or longest, okay, sometimes when you think about wavelength, we might think about that as longest and shortest, because remember, wavelength is a length, and it's this length from the beginning of the waveform to the end of the waveform. It's this length right here, okay? So lowest or shortest. So our longest wavelength are radio waves, okay? Then we've got microwaves. We've got infrared. Then we've got our light that we can see, our visible, which is here in the middle, all the colors that we've talked about. Then after that is ultraviolet, X-rays, and then gamma rays are the ones with the shortest wavelength. Okay. Then arrange them from highest energy to lowest energy. So this is going to be kind of the opposite of this. Okay, so I remember saying to y'all that if you've got the order down in one way, you can use that to help you with the other ways. So wavelength is one way we order it. Another way that we order it is energy, and energy goes along with frequency. Remember, okay, so my waves that have the highest energy also have the highest frequency, and then lowest energy goes along with lower frequency. Okay, and so then this is going to be this same order, just like flip flopped. Okay, so my highest energy are my gamma. Those are the ones that are the most damaging to us because they're a high frequency wave. Then X rays, then ultraviolet. Visible again is in the middle, it's always in the middle. Then infrared have lower frequency, microwaves, and then radio. And remember, frequency and wavelength are inverse of each other. Okay, if one goes up, the other goes down. So we see that reflected here. These are long wavelength going to short. And if wavelength is inverse, that means we've got low going to high. Okay, so long wavelength, low frequency, high frequency, small or short wavelength. Okay. Okay, so that's the electromagnetic spectrum. Next, we'll talk about refraction. Okay, so what does it mean for a wave to refract? So I showed y'all this, my giant vase with the meter stick. So we have the meter stick, and as it goes into the water, it looks like it bends. Okay, instead of going this way, the meter stick appears to be bent or broken. So when a wave refracts, what happens is the wave bends. And this is happening as it goes into another material. Really, what's happening is the wave speed is changing. And so when the wave speed changes, as it goes, say, here from air into water, then that wave is going to bend. It's going to change direction. So that's refraction. It's bending as it goes into another material. Transparent materials can have an index of refraction of 1 and then to around 2.5 for a diamond. What does the index of refraction indicate about how light will behave in a given material? So what the index of refractions is our N value. That tells us a couple of things. It tells us how much the light waves will bend. And that's really telling us how much the speed will change. So let's say tells us how much light waves will bend, how much the speed will change. So if you've got a lower index of refraction, that generally denotes a less dense material. Your light waves are not going to bend as much. Their speed is not going to change as much. Whereas for something like a diamond, which is all that compressed carbon, I guess, right? That's what a diamond is. That's denser. So your light waves are going to bend more. Their speed is going to change more from that speed of light in a vacuum that we've talked about. Okay. So as N values are higher, that means the material is denser. So light will bend more. Okay. So that's kind of a basic explanation there. So then in air, light travels at a speed of 3 times 10 to the 8th meter per second. That's the same as a vacuum. It's really not exactly that. I mean, the index of refraction of air is 1. We use 1. It's really like 1.000227. So it's not exactly that speed, but we can approximate it. Okay. A diamond has an index of refraction of 2.49. What is the speed of light in a diamond? Okay, so this is where we use this equation. Where N is our index of refraction, which we just talked about. C is our speed of light in a vacuum. And that's 3 times 10 to the 8th meters per second. And then V medium is the speed that we want. Okay, so with this equation, we might be solving for index of refraction. We also might need to flip these two, okay, to solve for speed. That's what we're going to do here. So we're going to take 3 times 10 to the 8th, and that's a constant. The speed of light in a vacuum is always the same, and that's on your equation sheet. I didn't bring an equation sheet home, but it's on there. It's given C as a symbol. So we're going to divide that speed by 2.49. This is like your top speed. You cannot go faster than the speed of light, okay? And then what we're really doing is N is kind of like a ratio type number. It's like a comparison between the speed of light in a vacuum and the speed of light in another material. And when we divide speed of light in a vacuum by that, we're going to get what that slowed down speed is, okay, in the material. So, okay, I had to borrow a calculator for my son because I left mine at school, I think. I hope it's at school. I don't know. So the easiest way to do this problem, right? You've got this 10 to the 8th here. You really don't need to use it in your calculation because what you have is a huge number, 3 times 10 to the 8th, divided by a really small number. The way I would recommend doing this is divide these two numbers, 3 by 2.49. So I'm going to do 3 divided by, can y'all even see that? Okay, 2.49 equals 1.2, okay? So that equals 1.2, and then you can just take this 10 to the 8th and append it, okay, or tack it on to the end of that because it's still going to be there. If I divide, and I'll just show y'all so that you, and then I'll be at time for this. So this is 300,000,000, and then if I divide that by 2.49, it's still a huge number, okay? I've still got all 8 digits there. So I would recommend just divide 3 by the index of refraction, and then you just kind of tack this on because it's still going to be there. Hopefully that makes sense. And that's going to be in meters per second. Okay. All right. Continuing in the next video.